Okay, the first thing we're going to do is open Spartan Student Edition and sketch the molecule diiodoethane. So we'll come up here to the new tool. We can use the organic menu in this case. Have a tetrahedral carbon, connect it to another tetrahedral carbon, and then put an iodine on each of the carbons. And if we click the view tool here, it'll automatically put the hydrogens on for us. Okay. So now we've sketched the molecule, we're going to go up and we're going to select the 4 atoms that are involved in the dihedral bond. So to do that, we're going to go to Constrain Dihedral. And then we'll select iodine, hold the shift key down, carbon, carbon, iodine, keeping the shift key down in between. Okay. Now we're going to click on the lock button at the bottom of the screen here, and we'll check the profile box. We're going to enter a range of angles from 0 to 180 degrees. In 12 steps. And we're going to go to Setup Calculations. This time we're going to choose the energy profile. In the gas phase using MMFF, Molecular Mechanics Calculations, and then click the Submit button. We'll give it a name, call it diiodoethane, and click Save. When the dialog box pops up, we'll click OK. After the calculation is completed, we'll click OK. Do we want to open it? Sure, yes we do. Okay. And now we'll click on the spreadsheet icon. Now we're going to choose a molecule list. Okay, so we're going to have to add, and we want relative energy. Relative energy. Under the molecule list. There it is, relative energy. And we're going to make a table in our notebook, okay, for the dihedral angle and the relative energies. Okay. So when we close the table, so here's the angle is 0, and then 15, and then 30, etc. You're going to want to write down all these relative energies at all the different angles. Okay. All right, then we're going to close the table. And we're going to click on the graph icon. Click on the big plus sign, and we'll choose relative energy, and then click the create button, and it'll now graph the relative energy versus the angle. Now what we can do is we can orient our molecule so that we're looking down the carbon-carbon axis as if we were observing a Newman projection. And for each of the different dihedral angles, we can then sketch a picture of the molecule. You're going to want to sketch the picture of the molecule at all of the peaks and all the valleys in your energy profile diagram. So in other words, at 0 degrees, like we have it right here, And at this valley right here, how can I click on this thing? Here we go. You have to move it. Reset. There we go. Click this forward arrow until we get to the first valley there. And then you can sketch that Newman projection and continue to click the forward arrow until we get to the top of this hill, and we'll sketch that Newman projection. And then continue to click the forward arrow until we get to the bottom hill in the bottom valley here, and we'll sketch that Newman projection. So we're going to sketch it at the two tops of the hills and the two bottoms of the valleys. And then you're going to answer your post-lab questions.